Okay, good morning, class. So today we're looking at measurements. So we just looked at the sums that you had problems with homework. Now we're going to do the exercise 16.2. The example to exercise 16.2. Well, 16.2 is on page 363. And the examples to this is on page 300 and... Sorry? Okay, so this is on page 363. Okay. And the exercise on page 367. Okay. Right, so let's go. Okay, so here we are told, as we of course the video, we can read through this, as I would like to keep this video really short. Okay. Alright, so with this we concluded that the area or the volume of the cylinder is going to be pi r squared h, while the surface area is going to be 2 pi r h plus 2 pi r squared. The full lesson can be found in the description box below. Also, a cylinder can be oblique, which means to say it's tilted there. If a right cylinder and an oblique cylinder have the same base and height, then the volume will be the same. Okay. So now we are on the next example. We are on example 1 on page 363. People, the question says the diameter and the height of a right cylinder are 7 centimeters and 20 centimeters respectively. People, what does that mean respectively? It means to say in that order. So the diameter is 7, whilst the height is 20. That's when it says respectively. Okay. He says calculate correctly one decimal place of volume. People, how do you calculate the volume? It's going to be area of base times height. So the area of this base, area of a circle is going to be pi square times height. So it's going to be pi. What's my radius? Remember that the radius is half your diameter. So it's going to be 7 divided by 2, which is 3.5, or 7 over 2. So 3.5. So it's 3.5 squared times the height, which is 20. And as you can see, both is in centimeters. If it's not both in centimeters, the one must be converted to the other. So 3.5 times 3.5 squared times 20. Why is that at 3.5 twice? Then let's say pi. Pi times 3.5 squared times 20. You get an answer of 245 pi. And of course, I want to do one decimal place. This SD 769, comma 7. What? Centimeters cubed. As you can see, centimeters. Okay. Is there any confusion? Am I moving too fast? No. Okay. I'll try and move a bit faster. Okay. The total surface area of the cylinder. How do you calculate the surface area? Perimeter of base. Perimeter of base times height plus 2 area of base. Okay. So the perimeter of a circle. The perimeter of a circle is 2 pi r times height plus area of the base. How do you calculate the area of a circle? Pi r squared. Not so. People, why do you think they're saying 2? The top and the bottom. This is the base. This is the top. Can you see that? So sometimes I would say the top is open. The top is open, then I only go one area. Can you see that, people? But it wouldn't affect your volume. What can fit inside? You guys understand? So they didn't mention. If they don't also mention anything on the top, we leave it as is. Okay. So what do we have? Twice area of base. How do you calculate the area of a circle? Pi square. So let's go. It's going to be 2 pi times. What's the radius? 3.5 times the height, which is 20, plus 2 pi. What's the radius? 3.5, and it must be square. Let's put that in a calculator. It's 2 pi times 3.5 squared. No, just 3.5 times 20 plus 2 pi times 3.5 squared. Sorry? It's going to be 329 over 4 over 2 pi. For one decimal place, will be 516,8 centimeters. Is that the right answer? So what are you saying earlier on? Y squared. Is there any confusion? Any confusion, people? No? It's very simple, no? Okay. Don't think it's too simple and you don't practice it. Okay. So now we're going to look at a right circular cone. A right circular cone. Okay. Which page are we on now? 364. Okay. 364. So here we are talking the right circular cone has a circular base and a lateral surface that when it's unrolled, it's a sector. So what is a sector? It's part of a circle. Okay, sector. Looking at the circle, and you take the area of a circle that is divided by 2 radii. A circle that is divided by 2 radii, and a circumference. So this area here is called a sector. It's a sector. There's a minor sector, and this is of course the major sector. No? No, the thing is not smiling. No. Okay. What's wrong with you? Okay. So, here we are told to unroll the sector of a circle with an arc length, the circumference of the base and the radius, the slanted height of the. Okay, so let's read again. A right circular cone has a circular base, which is that thing, and a lateral surface. When unrolled, is the sector of the circle with an arc length, the circumference of the base, and the radius, the slanted height of the cone. Okay. So the volume of a cone, people, the volume of a cone is going to be a third area of base times height. In this case, it's going to be a third. The area of the circle, power squared times the depth of the object. While the surface area of the cone is simply going to be the area of the base, which is power squared, plus, and to calculate the area of that sector, it's going to be pi r s, which is the slanted height. Okay. Guys, okay? Can I move on? No? Okay, so the question is, what is S? S is the slanted height. Okay. And if you say height, then is the depth of this object from there to there. That is your radius. So if you see you got a right angle triangle, how do you think you're going to calculate is? Pythagoras. Okay. Okay, so here they explain it further, how they get that formula there. People, if you're one of those girls that needs to know, you go through this. Otherwise, you can find it, the full lesson in the description box below. Okay, people, it says here, and this is on page 360, the volume of the right circular cone is 12 pi centimeters cubed. So the volume is given as 12 pi centimeters cubed, and the height is 4 centimeters. Calculate the radius, okay, of the base. People, so the radius, you see what we are given is the volume, not so. So in other words, I must use the volume formula. So what's the volume of a cone? It's area of base times 1 over 3, area of base times the depth of the object. So it's a third times. How do you calculate the area of a circle? Pi square times the depth of the object, 4. And what's the volume equal to? The volume is 12. How do we get all squared on its own? Divide both sides by a third pi times 4. It's a third pi times 4. Pi's cancel, of course. 12 divided by 3 is 9, 3. 3 divided by 30 is 9, I think. No? So therefore, r squared is going to be 9. Therefore, r is the square root of that. Not so. Which is 3. Remember, if I introduce square root, what must I not forget? Plus minus. But can r be negative? No. So we're talking about length. So just 3. Is there any confusion here? Am I still moving at okay speed or am I moving too fast? Okay. I don't want to lose you guys. No? Well, let's look at B. B says calculate the slanted line. Okay. But if you look at the slanted line here, it's there. We've got 4 here, and what's the radius? 3. Pythagoras. So sine s squared is equal to 3 squared plus 4 squared, or 4 squared plus 3 squared. So it's going to give you 25. So the slanted height is 5 centimeters. Okay. As you can see, the surface area of the cone. How do you calculate the surface area? No, this one is different. The area of the base, which is pi r squared plus pi r. Okay, which is in the what is that? The literal section of that. Okay. So what is pi? So pi times what's the radius? 3 squared plus pi. What's the radius? 3 times the slanted height, which is pi. So it's going to be 9 pi plus 15 pi. What's 9 plus 15? 24. 24 pi. And then we can just put that in the calculator. Okay. 3 squared plus pi times 3 times 5. 24 pi, which is 75 comma 4 centimeters. Okay. Any confusion there? No?
Subtraction 1 does not have
Did I say? If I didn't specify, you can write in 1, 2, or 3. Doesn't matter. This is the same one, eh? Yep. I think I've cut it twice there. Sorry about that. A sphere and a hemisphere. Let's do the pause again, yeah? Okay, next page. I'll change it now. Alright, so at this point we looked at the volume of a sphere, which is 4 over 3 power cubed, while the volume of the hemisphere is 2 over 3 power cubed. The surface area is going to be 4 over 4 power squared, while the surface area of a hemisphere is going to be 3 power squared. For those of you who want to know how to solve it, or they come to that, you can go through this here. Otherwise, you can find it in the description box below. Okay, go for this. Right, so now we're on the next page. We're looking at the example on page 366. 366. And this is for exercise 6.12 on page 367. So here we are told that a solid in the diagram is made up of a hemisphere, which is half a circle, of a radius r placed on the top of a cone. The slanted height is s and the height is h. If r is equal to 10, so here we told that r is going to be 10 millimeters there, and your height of 20 millimeters. Calculate correct one decimal place the slanted height of the cone. The shot by Pythagoras. Okay? So let's go with the slanted height of the cone. So that would simply be s squared is equal to 10 squared plus 20 squared. As you can see, this is a right angle triangle. Not so. Okay, the board is just acting up now again. So that's going to give us, people settle down please. 500, the square root thereof is going to give you 10 root 5. Okay, did I say to how many decimal places? Correct one decimal place, which is 22, comma 4 millimeters. Okay. People B. In B, they ask you to calculate the volume of the solid. So the volume of this thing is going to be basically the volume of the hemisphere plus the volume of the cone. Not so. The volume of the hemisphere plus the volume of the cone. What's the formula for the volume of a hemisphere? 2 over 3 power cubed plus the volume of a cone. It's going to be a third area of base, which is power squared. Remember that is not going to be a base, no? Okay, so that's it. Just give me a minute. So it's going to be a third power squared, which is area of base times height. Okay, you're saying this is wrong. What should it have been? But remember, this is a hemisphere. It can't be 4 over 3 because the volume of a sphere is 4 over 3. Can you see that, people? 4 over 3 power cubed. So the volume of a hemisphere, which is half of that, is going to be 2 over 3 power. Understand, Michael? Okay. So that will be 2 over 3 pi. What's the radius? 10 cubed plus a third pi. What's the radius? 10 squared times the height, which is 20. Let's put that in a calculator. 2 over 3 times pi. Whoops. 2 over 3 times pi times 10 cubed. Let's put 1,000 plus a third pi times 10 squared times 20. Is your 4,000 over 3 pi, which is also equal to 4188, 4188, comma, millimeters. Is that correct? See, any confusion, people, other than dividing that by 2? Yes, 2 over 3.
But you said it's not about the to another.
Yeah. Just coming back to this here, where the confusion is. You remember here, when you're looking at the volume of a sphere, volume of a sphere is going to be 4 over 3 pi r cube, whilst the volume of the hemisphere is half of the sphere divided by 2. So if we divide 4 over 3 by 2, that is where I get 2 over 3 pi r cube. Okay. Right. People, any other confusion there? No. Okay, so let's look at the next question. Yes? 4188, comma, 8. Okay, can I move on? Let's look at C. C says the total surface area of the solid. So the total surface area is going to be the surface area of the cone plus the surface area of the hemisphere. Okay. Now, if I look at Isakanya Michael, the sums are on the board, not outside. Who are you watching outside? Huh? Were you making eyes for outside? Who's that thing? Is that your lunch? Coming from people, just remember the surface area of a cone. If I work on the surface area of a cone, it's going to be power squared plus power r is. That's of the cone. So this here is the literal part of it. Okay. This is this part. However, the pi r squared is the circle here. Not so the area of that circle. Now, is that circle exposed here? No. So should I include that in my surface area? No. You guys understand? Okay, let's go again. We're looking at the surface area of a cone. The surface area of a cone. This pi squared is this part of the cone. That's all. And pi r s is the lateral part of the cone. This part. That's all. Now, with that hemisphere on top of this cone, am I going? Is that part of the external surface area? The total surface area. Remember, what is the surface area? It's all this on the outside. Can you see that, people? So, can I include this circle here? No. So, I'm going to omit this part in the calculation. Okay, so I just write pi r. Let's look at the other shape. How do you calculate the surface area of a hemisphere? 3 pi r squared. But remember, that's going to be 2 pi r squared plus pi r squared. Where does this pi r squared come from? If you're back here, that pi r squared is coming from this, when I explained that part. Not so. Now, with that shape being constructed, is this pi r squared exposed? No. So that is also omitted. Okay. So how do we work this out now? So it's going to be pi. What's the radius? Times the slanted height. 22.4 plus pi, the radius, 2 pi, and the radius is It's simply going to give us pi times 10 times 22.4 plus 2 pi times 10. Gives you 244 pi, which is 766.5.
So it's been studied.
Sorry?
It's been
The 10 squared.
not being read yet.
Okay, so then this is wrong. Eh?
The last one.
Oh, I see, I see. This must square must come here. Yeah. Okay. Thus, 1332. 1332, comma 0.4 centimeters or millimeters. Okay, is that the right answer? No. What's the answer there? 31,000? Yeah, so what they did was, instead of saying 22.4, they used this. So whether you say 10 root 5, 1330, comma 8. You guys understand? Because this is a rounded answer here. Okay? That is why I got this answer. So in the exam, whichever one of the two numbers you use, you're going to get the full marks in both cases. In any of the two. Okay, you guys understand? Any confusion?
So why are we including the radius which is in related to the total surface?
Sorry?
Why are we including the radius which is in without calculating?
Because when we're calculating the area of this part, remember the area of a hemisphere is going to be a 3 pi r squared. So the radius of this hemisphere is 10. We're looking at the cone. The volume of the radius of that cone is 10. So I have to use 10. I don't understand why wouldn't you want to use 10? Maybe you can rephrase your question? Then ask. Are you thinking that the 10 is inside? Sorry? Since total surface area, yes? Yeah, we're not including the circle because if I must build that cone, that circle is not exposed to the outside. Okay, so when we're working out the surface area, we're working out what is outside. You understand? The outer figure. So if I must paint the solid figure, am I going to paint that circles on the inside? No. Not so, it will only be on the outside. That is why I've omitted those two circles. Okay. And did I write here 2 pi r? It's supposed to be 2 pi r squared. No? Okay, so I'm going to just do example 2. It's a breakdown, Right. So in example 2 on page 366, we are told that the sphere with a diameter of 105. So if the diameter is 105, the radius is 52.2. 52.5. 52.5. Okay. The diameter of is 105. The right cylinder with a height of 157.5 have equal volume. So the volume of the sphere is equal to the volume of the cylinder. Okay. Volume of the sphere is equal to the volume of the cylinder. Give, calculate the diameter of the cylinder. So if the volume of the sphere is equal to the volume of the cylinder, how do you calculate the volume of the sphere? 4 over 3 pi r cubed is equal to, okay, the volume of a cylinder is 2 area of base times height. So it's going to be pi r squared times height. Okay, so looking at the sphere, so it's 4 over 3. 4 over 3, pi. What's the radius of this? 52.5 is cubed is equal to pi. Now we're calculating the radius of this piece. Can you see that? So it's going to be r squared times the height, which is 157.5. In other words, I must get r on its own. Not so. So I divide both sides by pi times 157.5. Pi times 157.5. That of course cancels. So r squared is equal to, it's going to be 4 over 3 pi times 52.5. 52.5 cube over pi times 157.5 gives you 1225, and the square root thereof is 35 centimeters. Alright, you guys understand? Is that correct? They wanted the diameter, yes, absolutely. So therefore, the diameter is going to be twice 35, which gives you 70 centimeters. Right. With that, you should be able to do exercise 10.2. Okay. People enjoy the rest of your day. Good morning, good afternoon, class.